Yeah.
Hi everyone, welcome to Triangle Workshop. Today's guest is Jain, who is at UC Berkeley. He's a CS PhD student, and he focuses on machine learning to enhance developer productivity tools like program analysis, synthesis, and repair. He holds an undergraduate degree from IIT Bombay, where he researched NLP robustness and computer vision. And he's worked at Microsoft Research India, and he's currently an intern at Meta. So thank you very much for joining us, Nam.
Thank you. Thank you for having me. Okay. Yeah. So I'll be presenting LiveCodeBench, which is on holistic and contamination-free validation of language models for code. And like it was a really big joint group effort, like very fun with a lot of friends at Berkeley, MIT, and Cornell. So yeah, let's get started. Maybe I don't need to present this much, but just for this audience, like why should we care about LLMs plus code? And yeah, I'm not going to say something which is totally out of the box, but yeah, code and language models, they are being used for improving productivity for software engineering, data science. And last year there was this benchmark called SweBench, can language models resolve real world GitHub issues, where you take a GitHub issue, you pass it to a language model, and it will generate a pull request for you. And you can check if the pull request is correct or not based on test cases. And back then when it was out, it was a fairly complex benchmark. Like if I looked at the benchmark, I don't think I could have solved a lot of questions within 10 minutes, let alone solve the entire benchmark. But to somewhat everyone surprised, but yeah, at some point expected. I think this was, I guess, the last 2 or 3 weeks. There was a new sort on the sweep and slide benchmark for every 2 days of the last, I think, 2 weeks back. So yeah, we started, I think, back then in 2023 from, I guess, almost 2% accuracy. And currently, like on the SweBench Lite version of the benchmark, like models have continuously, or the agent systems have continuously improved so that the performance increased from 26, 28, 30, 38, and to, in fact, 40 now. So that's quite remarkable. And that just tells you the rate of progress with maybe a little bit of asterisks. Then another reason why I'm particularly interested in coding language models is coding is usually affiliated to reasoning and planning. So perhaps code language models show better reasoning performance. They have been shown to improve math performance, and they are linked to, yeah, general reasoning. But yeah, we don't have very compelling evidence just because it's very hard to do very rigorous experiments at these scales. And finally, I think this is perhaps the cool part going forward. Like code will be the language of AI systems. If you're taking an action on the computer, you will need to use some program to run that action. So, I mean, this is not something new. Like people have been doing this in the past, like semantic parsing. We have some version of that with tool usage currently, but you can also have like code as actions, basically where you can control the computer using code. You can just write arbitrary Python. You want to do that or not is maybe a different question. And yeah, a lot of people have been looking into that. Like there's this very nice survey on the same topic that if language models are the wizard, then code is the one. So yeah, this is how agents can interact with the real world. Yeah, they can communicate to the users with natural language, but if they have to take some action, they have to generate some form of structured output, which you can affiliate to code. I guess I'm taking the broader picture of code, which is, yeah, any kind of structured output which you'll semantically parse to produce some action. So yeah, this was, I think, somewhat like obvious, but yeah, exciting area around language models plus code. So let's come to benchmarking because yeah, models are improving very quickly, and this is what we are here to talk about. How are code language models evaluated? So code is like long form generation. So given some specification, that might be a natural language question, that might be existing code, you're generating a sequence of text as output. And back then, if it was 2018 or 2020, I would have said, yeah, maybe let's use Blue, which measures like token level similarity, that you tokenize the code with and take a ground truth code and see if how much overlap is there. But here is where things change. We can execute code. And given this ability to execute code, we can get some thing about correctness of the code. And functional correctness-based evaluation has become standard at this point in this domain. And it offers better reliability than Blur, like metrics. Blur, for instance, would like code, there can be a lot of semantically equivalent possible choices of code. And if you're just doing similarity on the surface form of the code, then you will miss out on many equivalent programs which are correct, but which will grade as false. Similarly, you can change the code entirely from changing just one plus to one minus. So yeah, perhaps you're not measuring the right thing if you're just doing text similarity. So functional correctness is very important. So let's talk about HumanEval, which is, I guess, this thing we'll come back to again and again. So this is like 164 manually written problems. This was done by OpenAI back in 2021 when they released the Codex model. And here, basically, there is a prompt where there is a function with along with a doc string and some example test cases, which is embedded in the doc string. So one doc string, an example problem can be def encode message, where you have to write a message that encodes the input string in some specified manner. Particularly, you have to swap the case of the letters and then change vowels to like two places ahead of vowels in the alphabet. So yeah, test changes to TGST. And someone manually went down there, thought this would be an interesting problem to test language models for. Not sure why this particular one, but yeah, this is what's comprises these 164 written problems. And for evaluation, we have like hidden input output examples. So yeah, you cannot just hack your way around the problem where you write two if conditions that if message equal to test output TGST, if message equal to this is a message output this and get over with it. There are some hidden test cases which would try to check overall correctness of the code. Of course, this is not possible in general because you can like yeah, it's you cannot check if a code is equivalent to another code using just test cases. You have to do formally verify them. But yeah, it turns out that it's usually good enough if you just use test case based evaluation. So yeah, that's what is standard in the field. And how are people evaluating performance? So this is a nice metric which has some nice statistical analysis or like statistical properties rather. We use pass at the rate k metric. So basic intuition for it is that you sample case if you sample k samples from a model, what is the probability that at least one of the generated sample passes all the test cases or is correct? So a simple way to think about this would be that maybe you are scrolling all the Copilot generations in the sidebar, and you're trying to check if any one of the generated sample is correct or not. So this is something somewhat practically relevant metric that maybe if Copilot is showing you five generations, then if pass at the rate 5 accuracy is good, then yeah, maybe your model is doing good. And instead of just sampling just generating case samples from the model, we will try to estimate a low variance estimate of this. So particularly, you will generate n samples from the model, which is greater than k. And then you can use basic combinatorics to find out what is pass at the rate k by, yeah, checking if, like, what is the chance that if you take k elements out of n elements, at least one of them is correct or not. So yeah, it provides you yeah, different intuitions. So like pass at the rate 1 would measure that is any one of the model generation correct or not. But pass at the rate 2 would be higher than that. It would check that, oh, you have two tries at the problem. So what is the chance that at least one of them is correct? So let's come back to 2021. Yeah, back then I was working on program synthesis. I was still working on program synthesis at MSR India, but I was doing like single line pandas programs. So like trying to do data science code. And then OpenAI comes out with this HumanEval benchmark, which is like multi-line, lots of complex natural language. And it seemed a very hard benchmark back then. And HumanEval, they released their model performances for the Codex model. And yeah, they have pass at the rate k with k equal to 1. Maybe that's the column we should focus on. And yeah, like I guess 12 billion was quite a big size back then. And we were seeing 30% pass at the rate 1. So it seemed a very, very challenging benchmark. We did not know how to do this very well. But let's scroll and let's see what happened in 2024. So recently we have an open source language model, let's say with Llama 3, and like it gets 81.7% with the 7 dB model. And almost all the frontier models currently have pass at the rate 1 greater than 70. And recently, multiple models have even crossed pass at the rate 1 value of 90 on this HumanEval benchmark. So something is, really amazing recent race of progress. So yeah, and I'll come back to again. So what are the issues in the current evaluations, given that like what can we read into it? Are there some caveats that we should be focusing on? So I guess, yeah, the crux of the talk, data contamination and overfitting. So this is something that I looked at, I guess, back in 2022. Yeah, you have a rolling max function. This is an example from HumanEval benchmark, where you are basically trying to find the cumulative maximum till a certain point in the array. And yeah, models sometimes do reasonably well with this. This is somewhat common problem, but it is somewhat common problem. So if you look at Stack Overflow, you will find exactly same question, maybe differently worded, and a very interesting way to solve the problem with using the Walrus operator, which I did not know about when I was trying to do this. But yeah, so exactly same problem occurs on the web. And it's not just Stack Overflow. There are multiple copies of these benchmarks also lying around on the web. And people do a lot of deduplication where they try to remove similar samples from the web. But of course, it's still a very hard problem. You can always adversarially change the program so that deduplication or removing these samples from the training sets, it's hard. And then people are training on these web sets for during pre-training. So it is very much likely that some form of these benchmarks are sweeping in into the web sets. So yeah, this is, I think, a very nice study from Cohere. So yeah, this was a nice study from Cohere where they were checking if the level of contamination, and it's a very like interesting idea. You take a original HumanEval problem, and remember that the HumanEval problem contains functions like definition, which is the function signature and the doc string. And what you would do is you would chop off the doc string at a point and just see if the model can predict the question itself. And to everyone's surprise, or maybe not surprise, the models can actually predict the question from the prefix itself. And it's also not something very obvious. So the submitted prompt to the model is you're given a string S. Your task is to check if the string, which can lead to any possible continuation, because what is a happy string? Nobody knows that. But the model exactly says that a string is called happy if its length is at least 3, and every 3 consecutive letters are distinct, which is very particular. Oh, where is this coming from? Exactly the HumanEval problem on the left-hand side. So yeah, and this is, I think, one of the frontier model. I think if you try all the frontier models out there, you'll see that one of them followed this. But yeah, Cohere, yeah, Mars did. So yeah, I'll also maybe continue in the same practice. But this is a interesting way to check if a model has been trained on a problem or not. And you can do this for different problems also. I think there are like other analysis on other benchmarks where people have shown this. CodeForces problems in particular are like models can, I think, predict the question name from the yeah, I think some prefix of the question. Similarly, for GitHub issues, I think if you provide the model with yeah, I think the issue name, the models can predict something about the question. So they are trained on some of these aspects. There is, I guess, further very nice evidence from how HumanEval seeps into the pre-training sets. So Pile and Stack are the standard open source pre-training sets. And as I said before, what people try to do is they would try to use n-gram deduplication, where they would try to find very similar examples in the pre-training set, which which are the same as a instance in the HumanEval benchmark. But what people would do again is n-gram overlap, which is not sufficient because you can maybe rewrite a variable name and then your n-gram changes. So if you change LST to my weird list, then yeah, you won't pass the deduplication test, and that example would seep into your training set. And then, yeah, you can say that, oh, I deduplicated my benchmark, but my HumanEval performance is 100. So what these people try to do, they try to use semantic similarity. Uh, and with semantic similarity, I think they were able to find that 18 to 19% of the HumanEval problems have a similar code, like 100%, top 100, one score 100, similar score in the stack. So for like 19% of the problems, it's right there in the stack. There are some reasons of this. Yeah, it's not totally a red flag. Maybe because HumanEval contains somewhat simple problems, well, considering the year is 2024. Like a lot of those problems might be very standard and common, and you probably want to train a model on those problems. But even then, I think a lot of problems have very similar problems that are occurring in the pre-training set, and it's entirely not clear what is the level of generalization we are expecting or going to see. Then, so this was the data contamination story, and I think we'll come back to it again and again. There are some other issues. This is maybe more centric to code and like programming languages. We are trying to evaluate these models on using hidden test cases. But if you're trying to do that, you need to ensure that, yeah, your test cases are actually hidden. And like this has been investigated in previous works where there was this original question in HumanEval, def common and n L2, where the prompt said that return sorted unique common elements for the two lists. But it turned out that the test cases were weak enough that if you just return a set of common elements, it just passed the test case based on some property or some randomness of the set. And you did not have sufficient test cases to actually check for the question correctly whether the list is sorted or not. So you would need to improve the test case quality to do something to give some reasonable estimate of the score. Otherwise, you are overestimating the performance of the model if you're just testing it on very weak test cases. So this is a problem in the original HumanEval benchmark. There have been works like Eval Plus or HumanEval Plus, which have tried to improve the test coverage and fix some mistakes in HumanEval and have been being adopted more and more, which is good. But yeah, again, performance improvements can mean a lot of things. Contamination, maybe your test cases are not weak enough, so you're just grading some random solutions as correct, and then you're seeing that saying performance is very good. A third aspect, which I think is becoming more and more important currently, is that focus beyond code generation. So currently, the models, we are just testing them on natural language to code capabilities. But then our hope or our dream is right now to use them as agents, and our belief is that, yeah, they will solve most of our problems. But these two things do not correlate very well, because when you're trying to build language model or programming agents, there are a lot of other things that matter. So you are generating code, but then you execute it, you take the execution feedback. Maybe to execute a code, you have to generate test cases. So a lot of the different things about coding, like a lot of software engineering life cycle elements come into the play here, which are not being evaluated currently. So there is a need for going beyond code generation and evaluate things like code repair, test case generation, etc. And the fourth question, which I guess I want to come back to again, is that, yeah, HumanEval is also becoming saturated. So recently, Cloud 3.5 Sonnet from Anthropic came out. And if you look at the HumanEval performances, as I said, the models have crossed 90% accuracy on this benchmark. So it is becoming somewhat saturated. And this also means that, yeah, model performances are increasing rapidly, and it's important to balance problem difficulty distributions. If you take very hard problem difficulties, then all the models will get 0. You cannot say anything if a model is better or not. Maybe you need to do some qualitative analysis, but you're not getting a lot of reasonable signal out of the benchmark. But at the same time, if the benchmark is very easy, which at this point for frontier models, HumanEval has become like that, you'll see that a lot of the bench models achieve similar performance. And then you're not able to say much more reasonable about the models, which is, yeah, not the point of the evaluation. We want to compare models and say if models are good or better based on some reasonable assumptions about the benchmark. So, like, as I said, there are some evaluation issues in code, and then, yeah, some more that I'll highlight further. So let's talk about fixing this evaluation crisis. And for contamination in particular, one very interesting way is to perform live evaluations. There have been some works which have also looked at beyond code, like LiveCodeBench. And the goal here is for we need to collect new problems on the fly, and we should also have reliable runtime harnesses for evaluating code elements, code language models. So how do we go about this? We have three stages. First, we want to automatically curate the problems from the web, and there should be a nice way to collect them, that they are like sufficiently high quality, they are covering diverse distributions that you care about. But a hard part or an interesting part about code language models is that we are using test cases for evaluation. So beyond just curating these problems, we also need to curate and construct these test cases. And we want to collect these or evaluate them using, evaluate the collected problems and tests on new models. Once you have solved the collect new problems, collect new tests. So let's talk about LiveCodeBench, but it's a very general story which I presented before. And maybe if we have time, I'll talk about some other work that we are doing in that space. So here we took competition coding problems, or somewhat interview style coding problems, where we collect fresh implementation and algorithm focused problems from weekly contests on LeetCode, AtCoder, CodeForces programming platforms. One very important distinction here is that we try to very hard to take a very diverse and interesting distribution of problem difficulties. That is, we try to remove problems which are too hard and with problems which are too easy based on some difficulty estimates, which so this is what a problem would look like. And again, this is somewhat different from what HumanEval does. HumanEval is very the problem statement is within the code, while here you're giving a somewhat big text prompt, and you're trying to predict the code from it. So like here you'll see that you're giving two zero index integer arrays, and you're trying to find the following values and something like that. So yeah, these are the kind of problems that LiveCodeBench evaluates, but we still do not have test cases. So in our work, we use language models for creating test cases themselves. So you can use language models to create okay, let me rephrase. From these competition platforms, you can collect ground truth programs that pass all the tests. So you'll see some user submission. Now, if you just can generate diverse inputs to these problems, then you can do some kind of differential testing between the new solution, model generated solution, and the ground truth solution. And we figure out very interesting ways to generate these adversarial test cases for evaluating models using generators. So language model will itself output a program which will generate test for evaluating another program. A bit complicated, but yeah, a simpler way to phrase is that, yeah, language model is inside a program which generates a lot of inputs. And you can use these inputs to differentially test with the existing ground truth solution. So another aspect that we are focused in LiveCodeBench is performing holistic evaluations beyond just code generation. In particular, in relation to programming agents, we have found like a few different tasks which are very pertinent. Particularly, given a problem statement, you can do code generation, but you can also give the model execution feedback from the code and ask the model to repair it. So here in this example, like the original code was incorrect. You provided the model with execution feedback on like some example test case from the problem statement, and the model was and we check if the model is able to repair the code or not. Particularly for repair, you have to also multiply this count by the maximum element, which was not done by the model. Another task that we focus on is test output prediction. Test generation, as I said, is somewhat important, because you're trying to verify if the code is correct. And if the model can then itself do it, then you can go beyond that. So from a problem statement and a test input, we ask the model, can you predict what is the expected output? And similarly, we have one more task on code understanding. There are a lot of different ways to go about it. One way is to document the code, whether the model can provide good documentation, but it is very hard to evaluate. Here we take an interesting route, which is based on some prior work, which is on, can the model predict code expected output for the code from the input itself, which tells you if the model is able to understand the code. And the reasoning is that like if you're trying to learn programming, you just don't learn to write generate code. You also learn to understand code, and you can walk through the code in your head. Can the language models do that? This is another aspect that we evaluate here. But so let's come to the findings, because yeah, there's a bunch of them, and yeah, there's a bunch of them in particularly to contamination as well. So LiveCodeBench collects these problems like over time. That is, we collect these problems in some regular time intervals, maybe 1 to 2 months, such that we have some like reasonable new problem sets. But this also gives us a very interesting aspect that we can annotate our problem statements with the problem release date. So we can particularly if say that you have these like these 10 problems coming from the month of May, these problems coming from the month in this time window. So using this, you can use time as a control knob, and you can basically scroll over time by filtering on the problems which were released in a particular time window or not. And based on that, you can evaluate models and different set of problems from different time. So what happens if you do that? Let's take a look at this plot where you have reported the model performance over problems from different months. So this May column, you'll see that there are four, for the four models, we have different like pass at the rate performance of the models. And this changes over time. And one very interesting aspect here is that for some models, we see a very stark decrease in performance after certain months. So let's take a look at the red curve with GPT-4o, and you'll see the pass at the rate 1 for the model is almost 80 in the month of May. And it drops to, on an average, let's say what, 45, 42, 45 after November. OpenAI claimed that the cutoff date for GPT-4o is November. And you see that there is a very stark decrease in like performance of the model after November, which somewhat highlights that it is trained on some of the problems from the past, and that's why it's exhibiting this high performance. It is not certainly that LeetCode changed the problem difficulties and make them much harder, but on the other side, that GPT-4o is actually contaminated. Similarly, DeepSeek, which is a like very strong open source model, which was released in September, exhibits very similar flavor where in May, June, it was performing better than original GPT-4. And starting in September, the performance decreased, and it's yeah, slightly around the performance or somewhat below the Gemini Flash model. So yeah, you can use these time-based evaluations to like account for different model release dates and evaluate the models more fairly by with some good confidence that the models are being evaluated and tested on new problems rather than just existing problems, which they may or may not have been trained on. The sad part is that the model developers, there is no incentive for them, and there are potentially negative repercussions if they provide what what are the data sets that they are training on. So using these kind of live evaluations tries to solve that problem of continuously collecting new problems and ensuring that the models are being tested on something new. So we have a very nice UI which can yeah, simulate this effect. So yeah, you're seeing this GIF which is taken from our website where yeah, you can scroll over time and basically filter the problems from different time windows. And what you'll see is that at the start of the GIF, GPT-4 Turbo is like quite low, but slowly as you go over time, it starts gaining up in performance, while some models, particularly the red colored models, go down, which highlights contamination in the other models, which uh, yeah, yeah, it was making this evaluation harder. But once the models are tested on new problems, you see that it's a stronger model than, let's say, DeepSeek Coder V2, which is also a very strong model, but yeah, its performance was like over amplified in the initial months because of contamination. So yeah, so far we have talked about contamination, which is explicitly training on these problems. But yeah, we also detected like a lot of overfitting with our benchmark. So we talked about HumanEval quite a bit in the past, but we are not still done with it. So yeah, here is a scatter plot where we compare the performance on HumanEval versus an easy subset of LiveCodeBench. And so on the y-axis, you have HumanEval. On the x-axis, you have LiveCodeBench easy set. And you'll see that there is this green shaded region where a bunch of models lie, which is almost along the x equal to y line. So if you see the like GPT-4 Turbo, it gets above 80% accuracy on both the benchmarks. But you'll also see that there is a red shaded region at the top where there are some models which are much above the x equal to y line. That is, there are a bunch of models which are better at HumanEval, but do fairly worse at LiveCodeBench. So what's happening here? You'll see that, let's take a look at this DeepSeek Coda 1.3 billion model. It gets 60% on HumanEval, while like various proprietary or larger models like Claude get fairly low, like 45 to 50% on HumanEval. But it's really, really bad on the LiveCodeBench problems, and you see that there is this reverse diagonal arrow in performance, which means that DeepSeek model is overfitting to HumanEval, and its performance does not generalize to other benchmarks like LiveCodeBench. And the nice thing is that we are not even talking about the full LiveCodeBench, which has like hard interview problems. This is just the easy set. And there are a lot of models which do similarly on both LiveCodeBench and HumanEval. So it highlights that a lot of the models are overfitting on HumanEval, where they overfit to a smaller distribution of problems. And as we saw that HumanEval is like single function interviews, like somewhat simple problems. And the problem distribution is not particularly large given you have 164 problems. And if you collect the right kind of data, perhaps you can overfit to that benchmark. And more on that, I guess, going forward. I'll talk about the pre-training, post-training setups. But basically, for HumanEval, it's somewhat, at least for me, it had become somewhat hard to gauge what model is good or bad, because you had like like various 33 models, 33 billion parameter models, which were getting performance similar to GPT-4. And it stopped appearing that is it a reasonable estimate of code generation performance or not. Particularly like GPT-4, I guess back in 2023, claimed to have 2 billion parameters, and DeepSeek Coder 33B was getting similar pass at the rate 1. And coding is particularly hard. You do not anticipate that this difference can be accounted easily. So there was definitely some suspicion about this. And using LiveCodeBench, you're able to show that, while on HumanEval, DeepSeek Coder performs very similar, it is actually somewhat worse when you take different problem distribution. So it is maybe overfitting to that benchmark, and it is not globally better than GPT-4.
Naman, can I just
Yeah.
interrupt you just for a moment on that one? It's particularly striking that you don't see anybody to the bottom right of the green, right? It's particularly interesting that you really only see people up in that top to the top left of the green. Could you imagine a similar exercise to the one that you showed us that Cohere undertook, asking them to complete the prompt? Could you imagine doing that for these different models and then seeing if there's something systematically different between the ones in green and the ones in red where you think they are overfitting?
I think that would be particularly interesting. But I think, as I'll talk about ahead also, it is not necessarily true that this is direct contamination. What can happen is that maybe these problems are trained on what people would do, as I say next, is they'll train problems on a lot of problems which are similar to HumanEval, just because you want to get best on that benchmark. So you might generate or collect a lot of data. There are different ways to do that. But maybe you collected a program, and HumanEval problems, as I said, are easy. Maybe you collected a program which has a problem which is composing to HumanEval problems, and you train the model on it. So HumanEval performance will go up, but it's not contamination because it's not the same example, but a superset example. So there are a lot of factors, but this is a very interesting. I'll probably try out that. That seems very interesting experiment. Thanks for the suggestion.
Thank you.
Yep. So a little bit of digression. base models versus instruction tuned models because there are some findings related to this. So what is the current pipeline when we are training language models? Yeah, this is again somewhat like super simple. So what we do is we pre-train these models on web corpuses, and at the end of the process, we arrive at something, at least I'll call it in this talk as a base model. And then we go through this SFT and RLHF phase, which is also called alignment or post-training, and you get these instruction-tuned models. So pre-training and post-training, they have like somewhat different behaviors. In pre-training, you particularly use web corpuses, while for post-training, there is a lot of options. What people do is they would collect human data, particularly if you're companies. But if you are in academia, what you might try to do is you might collect synthetic data, where you use a language model to generate the data. So let me show an example of a very strong technique, which is trying to collect synthetic data, using language models. Particularly, we would use some seed code snippets or seed snippets and ask a language model using this code as inspiration, try to generate one more problem that can be somewhat similar to HumanEval or the instruction format that you care about. And you would collect these generated problems and also collect generated solutions and train the model on this synthetic data set. But now this is where the somewhat of the problem appears, that the way you generate this synthetic data, there is a pretty strong incentive to correlate it with how your benchmarks look like, so how HumanEval looks like, which might also mean that you are collecting data which might be particularly tuned for HumanEval. And this is something that we talk about next. So let's first talk about base models. So these are all the empty shaded clusters. So you'll have like the DeepSeek base model. This is the Llama 3 8B base model. And yeah, even the 1.3 base model for the DeepSeek, which I talked about being very heavily overfitting. So the base models are very close to this x equal to y line. So the models which undergo pre-training, they do very well on both LiveCodeBench easy problems, and they do similarly on HumanEval. So it appears that the contamination overfitting is not happening from the pre-training set. Instead, if you look at the top, these are all post-trained or instruction-tuned models, which go through this instruction tuning pipeline of synthetic data, where you try to generate products similar to HumanEval. And our claim is that this is the phase which is responsible to majority of this contamination or overfitting on HumanEval. And there is some evidence of this. So in fact, just yesterday, there was this work, like recent paper from Cohere again, and they try to find like contamination or overfitting from post-training. So they claim so I talked about this OSS instruct approach or this evolve instruct approach, which is somewhat similar vein. They computed cosine similarity of the benchmark examples with the generated synthetic data. And for HumanEval, you'll see that particularly for evolve instruct, a lot of the benchmark is very, very similar to the like generated data. So cosine similarities are almost always greater than 0.7 or 0.8. And then you fine tune the model or post train the model with this data, and then you get very high you get very high pass at the rate one, but it probably means that you're just tuned it very well to HumanEval, and it does not generalize. And the corresponding model, which is I think the wizard coder model here, I think maybe this green model, it actually is heavily overfitting on HumanEval. Similarly, I think other models which are based on a similar instruction tuning approaches are overfitting, and it's because of this. You're tuning your fine-tuning data sets very much similar to how you're evaluating them, very much similar to the benchmarks that are used for evaluation. Then I think I'll maybe leave some time, so I'll maybe try to wrap up quickly. So I talked about holistic evaluations. So beyond code generation, we also evaluate other aspects like code repair or self-repair, test output prediction, and code execution. And you do see some scenario-specific differences. So there are some places where these like radial plot intersects or curves intersect with each other. it's not super common. There is definitely strong correlation between the model's ability to generating code versus generating tests. But sometimes some models might be better at one thing while not at the other. It also means that, yeah, you need to, yeah, if a model is doing well in one aspect but not on the other, you can perhaps use this evidence for improving your pre-training and post-training pipeline so that you train the model on somewhat similar tasks, at least, if not the benchmarks. So yeah, uh, yeah, you see that like there are differences in scenario specific. So I think we found some interesting observations, like all the proprietary models, like OpenAI models, Google Gemini models, etc. They're very good at tasks like self-repair or generating test cases, while a lot of open source models are not good at these tasks. Particularly, they are very much very tuned for just generating code. So it's possible that the data mixtures that we are training these models on are not diverse enough and not covering all the other tasks that matter also, which is somewhat important if you're trying to build like things like agents where we would care about these self-repair test generation capabilities. Um, so currently, I think we have a leaderboard which comprises 50 plus models. And yeah, I think this particular yeah, plot paints a very nice picture. So we released the first version of the benchmark back in March. And back then, I think the open source models were not very strong. Uh, and then we have recently updated the benchmark early June. And yeah, I guess back in March, the story was a bit more grim because you did not have Llama 370B, you did not have Eurex 8x22B, and all the open source models were like trailing considerably behind the closed source models. But yeah, this story is slowly changing. And I think this plot is already old. We added a new model, DeepSeek Coda V2, which you saw was top 3 or top 4 in performance already. So even above Llama 370B. And so yeah, basically, yeah, open source, and there is some active race between open source and closed source models. It appears that the closed source models are still performing at the top of the benchmark, but yeah, with DeepSeek Coda V2, Llama 3, this difference is slowly changing. But yeah, it's an interesting place, and yeah, it would be exciting to see how things turn up in the coming months as the AI arms race that people call it is taking up. So yeah, I think these were the primary findings. Uh, I'll also talk about some other aspects with the releases. So we have released all the model generations on the web. This is it's a somewhat cute class server that we use for analyzing model generations, and you can do some qualitative analysis on this. You can also check for contamination and other aspects. You do not need to run OpenAI again. But you also have some interesting findings. So yeah, this is, I think, a LeetCode problem, a hard LeetCode problem. And yeah, this is a GPT-4 turbo completion. One very interesting observation, which we find, is that GPT-4 turbo, in comparison to the previous versions of GPT-4, like the original GPT-4 that came out, writes a lot of intermediate comments on the in the code. And what this means is it probably gives you some insight about how the model is being fine-tuned or post-trained, and maybe they are trying to use these natural language comments, which may or may not correlate with some like chain of thought-like performance where the model is using extra reasoning tokens for writing these comments. But maybe it's also something to do about improving code quality. And yeah, there are models which are improving different aspects. You can analyze the solutions. Yeah, it's right there on the web page. So then yeah, maybe let's talk about some challenges and some issues with the benchmark, because yeah, I think this part is not given enough attention. And yeah, I think there are some nice statistical analysis people can do. So evaluation noise. Like LiveCodeBench currently hosts like 511 coding problems. And so we do a lot of we have a good discussion on in the paper about the types of noise that comes from evaluation or that causes noise in evaluation. So there might be noise because you do not have enough benchmark samples. So you're just not getting a fair estimate of the performance of the model. But there might be other aspects, and yeah, we go in paper in more detail. But the biggest aspect or biggest cause of noise in evaluation is probably number of programming problems. And 511 is a decent number. It's particularly higher than HumanEval, which has been the baseline, which just had 164 problems. And if you have 164 problems, you can do some statistical analysis, like bootstrapping analysis, and say that you have like plus minus 2% standard deviation if you're trying to compare models. Like, or 2% standard deviation performance differences do not matter is a better way to phrase it. With 500 problems, I think this number reduces to 1.5. I think it also depends on how optimistic or pessimistic or like what p-value you're considering. But yeah, having 500 coding problems is not enough. After filtering for contamination, let's say for DeepSeek models, you'll evaluate on problems released after September, these counts go down, which, yeah, basically in turn increases this standard deviation or this noise in the evaluation. So, and a lot of the things about current like LLMs, or I guess machine learning in general, always has been that you would only, yeah, people only look at the number. They don't really consider standard deviation noise. So even if you're beating a model by 0.5%, you're better than it without any like more rigorous analysis. And yeah, this is something that we are actively trying to combat. Um, yeah, one solution for this is to collect enough easy problems regularly so that you just don't run out of problems. And yeah, if you take all the CodeForces or all the problems from all the platforms, I think you can collect over hundreds of new problems every month. So perhaps that's not big of an issue. But we have tried to be very selective in terms of problem difficulty. And if you look at these problems that from all the platforms, particularly let's say CodeForces or these competition problems, these are actually quite hard even for the current models, particularly when you're trying to do single turn evaluation. We're trying to evaluate pass at the rate one. Like I think even GPT-4, when it was released in March 2023, they said that, I don't know if people have tried CodeForces here, but it uses an ELO mechanism where the baseline ELO it gives you is 1500. And GPT-4 on an average got an ELO of 300 to 400, which is like fairly bad. And I think if you take, yeah, I think it got an ELO of 1100 at its best, while the baseline or where you start from is 1500. So it actively goes down against average users which take part in CodeForces contests. And yeah, this leads to like pass at the rate one very close to zero, and then you're not really evaluating differences between models. And this is like GPT-4, which is already a very strong model. So most open source models, you'll not get any evaluation signal if you're just including very hard problems. So we have been very selective in terms of problem difficulty. Perhaps we need to search and find more easy problems, but we can currently collect only 50 problems every month, which for me is not a lot. And yeah, we're trying to combat this issue. So yeah, we have a little bit of time. I'll just spend 2 minutes and then yeah, we can maybe take it, open up the floor. So live evaluations beyond competition or interview style problems. We have this work, which I'll be presenting soon at ICML on R2E, where the goal is to convert any GitHub repository into programming agent environment. And I think at least the hypothesis of this work, and which I guess I've also conveyed during the talk, is you can execute code, which is where which allows you to do very nice evaluations. And with R2E Assist, we try to create a general framework where we take a GitHub repository, we try to make it executable, and we try to generate test cases so that you can evaluate on problems from new repositories on the web. There are still some things that we have to figure out what is a natural problem that you can extract from a GitHub repository, but we can successfully generate, make hundreds of repositories executable and yeah, use them for collecting problems. So yeah, something to look out for. I think that's it. Yeah, I'll leave the floor for questions.
Thank you very much, Norman. Really appreciate that. It's absolutely fantastic work. Are there any questions from people? Feel free to raise your hand and I can call on you. Eric?
Yeah, thanks, Norman. That's really cool. I sensed a lot of this stuff was happening in the background, but like you actually, the theory and the data you put together to like, this is really awesome just to see this. You mentioned like, having a standard deviation around performance, blah, blah, blah. But like that to me, even like from what you've presented here, massively underscores the issue that you have like the standard deviation at a point in time, and then you have the standard deviation across time as well for performance too, right? And so like, I'm not even sure now how to think about these evaluations because they're almost like these stochastic points on the, I don't know if you have any thoughts about, I mean, I know you've kind of alluded to it, but just like in summary, like how should we think about kind of stable measures of model benchmarking
Yeah,
in
I
Toto?
think yeah, I think that's a very important question, and not enough people are thinking about that. I think a good rule of thumb in the past, or back in 2010 to 2020, has been like very large evaluation sets. Like you mentioned, that had, I don't know, thousands and thousands of evaluation samples. And once you have enough problems, the good thing about statistics is that the standard deviation goes down quite rapidly. There's very nice work from like some of the co-authors on CruxEval, where they try to evaluate a different kind. They try to do more rigorous analysis on noise, and they find that 800 samples is a somewhat sweet spot, where yeah, it's not too costly to run it, but the evaluation noise is nice. So even if you have some noise over different months, when you average it over enough months, where you average it over enough problems, this noise is not much of an issue. Now, the big thing is, do you have enough months? Which, yeah, you might not have because you're filtering on some old problems. But yeah, I think the most reasonable way I think about it is, yeah, just try to increase your evaluation sets and hope things work out, which they usually do. Yeah, I hope that answers some of it. Yeah.
Yeah, no, okay, that's good to hear your thoughts on that. I appreciate it.
Does anyone else have any other questions? We've got 5 minutes before Naman has to go, and you probably have to go and do your job. Uh, can I ask briefly, how do you think? So, with the whole point of these benchmarks is that we can evaluate model performance in a consistent way. We keep everything the same, and all we do is we swap out the different model and we see how things perform. Right? That's all great. Part of that is going to be keeping the prompt the same. Part of it's going to be keeping the temperature the same. Do you have thoughts around whether we should expect the optimal prompt for one model, the optimal temperature for one model to perform on a benchmark to be the same across all the models? Or do you think that we're likely to see that sort of breaking up? This isn't a criticism of your work. This is like a general discussion point.
Yeah, I think this is a very good question, and we talk about it in the limitation section. So we took one reasonable prompt, maybe made tuned it a little bit across models, but especially when you're at a 50 models range and yeah, you're just one person, what can you do? So uh, but I think like particularly it depends on the kind of benchmark you're building. For competition problems, I think currently a lot of model developers are also thinking about them. And if they are thinking about them, they are some of these problems, some similar problems are in the training set. And I think that reduces some level of prompt variance. At least I hope that reduces some level of prompt variance, because the models are trained to predict the output, and the smaller choices and prompts do not matter as much. But again, maybe you do chain of thought style evaluations. Maybe you ask the model to do something like that. And I think things change considerably, and there is no uh, good way to think about it. And if you start considering prompt variance, I think this might be a bit pessimistic, but yeah, you might want to increase your standard deviations to 4x, 3x. Yeah, there is no good way, but hopefully for like problems which are close to how the models are trained for, I think you can sufficiently ignore the various in prompts and then hope things work out. Yeah, I don't think I have a, but yeah, maybe to your exact question, I guess I would say, yeah, in general, yeah, prompts and temperatures would just add to this like evaluation mess. And I don't think there is a very nice community figured way. What we can do is two things. One is just use same prompt for all the models, which we try to do here. And the other, which I guess people are doing now on MMLU and other benchmarks, which the model developers are releasing themselves. So they release their own numbers and they tune their own prompts. And I think you don't have them consistent. Even that can have some side effects. Like I think Gemini paper reported 32 shot performance, while OpenAI reported 8-shot performance, and then Gemini was slightly better. But what is going on? What's the difference? How do you evaluate it? I think, yeah, it's particularly hard in the language model space because of all these additional hyperparameters compared to good old image learning.
Yeah, absolutely. Thank you. Are there any other questions from folks? Maybe just briefly, and maybe this can be the last question. Can you talk about some of the practical, what do you know now about building benchmarks that you didn't know 2 years ago that you started, that was like, you know, a hyper practical thing that you've learned?
I think at least for LiveCodeBench, a lot of the motivation came from one of the some past work I did and the issues I faced when I was using the evaluation benchmarks. So like I think having good degree of correctness in like correct problems, having sufficiently correct test cases, which I talked about in the past, I think people really care about them because previous benchmarks did not have them, and this is one highlighting factor for LiveCodeBench. So I think I think these would be not rocket science. Yeah, have like correct sets, make it easy to evaluate, which I think I need to make more efforts into. Yeah, make the benchmark easy to use. Similarly, I think one thing that you do not anticipate is like how many things come up at like with prompts and other things, or like inference engines you have to set up that which also cause some degree of like noise and other things in evaluation. So I think particularly that as those aspects as well. But yeah, I think it's probably a deeper question. I'll maybe give it a more thought. I don't think I have something off the head.
I would
But
add that.
there's a very nice talk from Jason Wei at Stanford where he talks about like principles of good evaluations, where like taking a lesson from the history on what LLM evaluations are currently being used. So I think, yeah, some of those principles are quite nice, where he talks about somewhat similar things.
Would you mind just repeating the name again, please?
Jason Wei.
Oh, right. Thank you.
Yeah.
So on that note, we might just say thank you once again for a fantastic presentation. Very much looking forward to seeing what you do next, and all the best for the rest of the day. Thank you very much, Nevin.
Thank you. Bye.